Welcome to this episode of the CompTIA Tech Plus Prepcast by baremetalcyber.com. Let's begin. The infrastructure domain in the CompTIA Tech Plus exam FC0-U71 is one of the most critical areas you will study. It focuses on the physical and virtual elements that make up the backbone of all modern computing environments. At 24% of the total exam weight, this domain has the highest scoring impact, meaning your performance here can greatly influence your overall results. You will be expected to understand not just the names of technologies, but how they work together, how they are configured, and how they are maintained. This includes computing devices of many types, the internal hardware that powers them, the storage systems that retain information, the connectors and interfaces that allow components to communicate, and the networking and virtualization tools that bring it all together. Mastery of this domain is not just for the sake of passing the exam. It also equips you to succeed in real-world IT roles where infrastructure is the foundation for everything else. Understanding infrastructure is essential because it explains how hardware, connectivity, and system configuration combine to create a functional environment. Professionals in support, operations, and administration use this knowledge daily to keep systems running efficiently and securely. It directly connects to other exam domains. Applications depend on infrastructure to run correctly. Security controls are applied to infrastructure elements, and troubleshooting often begins with hardware or network checks. Knowing infrastructure concepts gives you the confidence to not only fix problems but also design systems that meet user needs and organizational goals. It prepares you to approach tasks logically, whether you are installing a new network card, expanding a storage array, or integrating a new device into an existing system. In everyday IT operations, infrastructure appears in many different contexts. Help desk technicians often work on tickets that require setting up devices, connecting peripherals, or diagnosing connectivity issues. System administrators may need to track and manage IT assets across multiple locations, ensuring that hardware is updated and functional. Deployment specialists might install and configure new systems to integrate into a company's network. Infrastructure knowledge is also critical for enabling secure and reliable connections for both local and remote users. Many of the problems that disrupt business operations, such as faulty cables, mismatched devices, or network bottlenecks, are rooted in infrastructure. On the exam, you can expect scenario-based questions that reflect these real-world challenges, asking you to identify causes, select the correct components, or recommend appropriate configurations. The scope of the infrastructure domain is broad, so it is organized into specific categories. Computing devices range from laptops, tablets, and smartphones to virtual reality headsets and Internet of Things devices. Internal components include the CPU, RAM, GPU, network interface cards, and firmware such as BIOS. Storage types include hard disk drives, solid-state drives, NVMe storage, cloud storage services, and network-attached storage systems. Interfaces and peripherals cover connection types like USB, HDMI, Thunderbolt, and various display standards, along with the devices that connect through them. Networking topics include protocols, wireless standards, common network devices, and communication models. Virtualization and cloud technology topics explain hypervisors, virtual machines, and cloud deployment models. This organized structure allows you to approach each subtopic systematically while recognizing how they connect to form a complete IT ecosystem. Objective 2.1, Common Computing Devices, requires you to recognize the capabilities, form factors, and use cases of different systems. This ranges from ultra-portable smartphones and tablets to more powerful laptops and desktop systems, as well as specialized equipment like gaming consoles and enterprise servers. Understanding the differences between devices helps you choose the right solution for each business or personal requirement. Emerging categories like smart televisions, wearable medical devices, and connected home appliances are part of the growing Internet of Things landscape. You may be tested on identifying these devices, knowing their typical purposes, and understanding their connectivity needs. Objective 2.2 covers internal components, the essential parts inside a computing device. This includes the Central Processing Unit, or CPU, which performs most of the computational work, the Graphics Processing Unit, or GPU, which handles rendering images and videos, Random Access Memory, or RAM, which temporarily stores data for active processes, Network Interface Cards, or NICs, which manage connectivity, the motherboard, which links all components together, and the BIOS, or UEFI firmware, which initializes hardware. Knowing what each component does, how it interacts with others, and how to diagnose or replace it is vital for configuration, support, and upgrades. Objective 2.3 focuses on storage types. Storage devices are categorized by factors such as volatility, speed, physical form factor, and connection interface. Mechanical hard drives offer large capacity at a lower cost but have slower read and write speeds. Solid-state drives use flash memory for faster access and greater durability. NVMe storage provides even higher speeds by connecting directly to the system's PCIe bus. Network-attached storage enables multiple users to share data across a network, and cloud storage allows data to be stored and accessed from anywhere with an internet connection. On the exam, you may be asked to select the appropriate storage solution based on a specific scenario or to compare performance characteristics between types. Objective 2.4 addresses peripheral devices, which are external components that extend a computer's functionality. These include printers, scanners, webcams, speakers, external hard drives, and uninterruptible power supplies, or UPS units. Installation methods can range from automatic plug-and-play detection to manual driver installation. The exam may give you a scenario where a peripheral is not functioning correctly, and you will need to identify whether the cause is related to compatibility, driver issues, or configuration settings. Understanding how peripherals connect and operate is just as important in the field as it is for exam success. Objective 2.5 covers interfaces and connectors, which are the pathways for communication between devices. These include physical ports like USB, DisplayPort, HDMI, and VGA, as well as wireless options like Bluetooth and NFC. Each interface has its own maximum speed, data type compatibility, and typical use cases. You may be tested on your ability to identify these connectors visually, match them to their functions, and choose the right type for a given device or performance requirement. Objective 2.6 explores virtualization and cloud technologies. You will need to compare traditional on-premises infrastructure to virtualized systems that use hypervisors to run multiple guest operating systems on the same hardware. Cloud service models, software as a service, platform as a service, and infrastructure as a service each serve different business needs. Deployment models include public, private, and hybrid clouds. The exam may require you to select the right model for a given use case, balancing cost, security, and scalability. Objective 2.7 looks at Internet services, including DSL, cable, satellite, fiber optic, and cellular connections. Each service type has its own strengths and weaknesses in speed, latency, cost, and geographic availability. For example, fiber offers high speed and low latency, but is not available everywhere, while satellite can serve remote areas but suffers from higher latency. Expect to compare and recommend service types for home offices, small businesses, or other specific environments. Objective 2.8 is networking concepts. Here you will review devices like routers, switches, and access points, addressing methods such as IP addresses and MAC addresses. Port assignments, communication models like local area networks or LANs, and wide area networks or WANs, and network security devices like firewalls. This knowledge is essential for diagnosing connectivity issues and designing functional network layouts. Objective 2.9 covers wireless capabilities. This includes wireless standards such as 802.11n AC and AX the differences between 2.4 GHz, 5 GHz, and 6 GHz frequency bands, and factors like interference and physical obstructions. You will also study wireless configuration options and coverage planning. On the exam, you may be given a scenario involving poor wireless performance and asked to recommend changes to improve speed, range, or reliability. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Infrastructure is not an isolated area of knowledge. It connects closely to every other domain in the CompTIA Tech Plus exam FC0-U71. For example, a misconfigured NIC, or network interface card, is an infrastructure issue, but it will also appear as a connectivity problem in a troubleshooting scenario. A device that cannot run a required application may not have the right internal components, making it both an infrastructure and an applications concern. Even in security, infrastructure plays a role. Physical ports, wireless access points, and connected devices must be configured and protected correctly to enforce security policies. Understanding how infrastructure interacts with other domains allows you to solve problems more effectively because you can see the entire context instead of just one piece. As you work through this domain, you will develop several key skills that apply directly to both the exam and real-world roles. You will be able to identify and compare hardware components, ports, and connectors by site and by specification. You will learn to match devices and services to the needs of a user or an organization, whether that means selecting a storage solution for a small office or recommending the right wireless standard for a home network. You will practice configuring hardware and software so they perform efficiently and remain compatible. These skills are not just theoretical. They are the practical, everyday actions that keep an IT environment running smoothly. This domain is given such a heavy weight on the exam because infrastructure forms the backbone of all IT systems. If the underlying devices, connections, and configurations are not functioning properly, productivity can slow to a crawl, or data may become inaccessible entirely. In many real-world roles, especially at the entry level, the majority of your tasks will involve infrastructure in some way, installing a new workstation, replacing a faulty cable, or configuring a printer for network access. The high weight of this domain reflects its central importance in both testing and daily practice. On the exam, infrastructure questions may ask you to identify a component based on an image or description, or to match a device to a particular use case. You may have to compare technologies, such as the differences between an HDD and an SSD, or between a USB-C connector and an HDMI port. Some questions will present a real-world scenario, like a user needing to connect a high-resolution monitor to a laptop, and require you to choose the correct interface. Accuracy here depends on knowing both the terminology and the functionality of each technology. While the Tech Plus exam is primarily multiple choice, you can expect performance-based questions that simulate real-world situations. These may involve identifying the cause of a connectivity problem, configuring a basic network, or selecting appropriate devices for a small office setup. In these cases, your infrastructure knowledge becomes the foundation for solving the problem. If you have a mental model of how devices connect, what speeds they support, and how they are configured, you can work through these scenarios efficiently and accurately. Beyond certification, infrastructure knowledge has immediate practical applications. You can use it to set up a home office network that balances speed and reliability. You can advise a small business on which devices and services to purchase based on their needs and budget. You can perform basic cabling tasks, configure storage systems, and connect peripherals. You will also have a foundation for understanding cloud services and virtualization, which are increasingly important in both personal and business technology environments. Many IT career roles are tied directly to infrastructure expertise. Desktop support technicians and junior system administrators often begin their careers handling hardware, peripherals, and connectivity. IT generalists, network technicians, and security assistants all need a strong infrastructure background to perform their jobs effectively. Even hardware-focused positions like repair specialists or deployment technicians require deep familiarity with components, connections, and device specifications. Knowing infrastructure basics opens doors to multiple career paths and supports advancement into specialized areas. To reinforce your infrastructure learning, make use of practical study tools. Flashcards can help you memorize connector types, acronyms, and component names. Watching teardown or build videos online gives you a visual reference for internal parts. Reviewing manufacturer specification sheets builds your familiarity with real-world device metrics. Whenever possible, get hands-on with spare hardware or use virtual lab environments to simulate installation and configuration tasks. These active learning methods make the concepts easier to recall on the exam and in the field. Be aware of common pitfalls in this domain. Many learners confuse port types, such as mixing up DisplayPort and HDMI, or misreading connector shapes. Others assume all devices use the same drivers or installation methods, which is not the case. Some require specific software or manual setup. Storage types are another area of confusion. Differences in speed, capacity, and endurance can have significant impacts. Cloud service model distinctions like infrastructure as a service versus software as a service are also easy to mix up. Knowing these frequent trouble spots can help you focus your review. Effective review strategies for this domain include grouping study material by device type, such as input devices, storage devices, computing systems, and networking equipment. Practice creating diagrams from memory to test your recall of how systems connect. Match terminology to specific use cases to simulate exam scenarios. It can also be helpful to revisit infrastructure after you have studied other domains so you can see how it supports and interacts with them. Building confidence before exam day comes from repeated interaction with both physical and virtual infrastructure tools. Quiz yourself frequently on connector identification, component functions, and storage technologies. Pay special attention to best fit questions, where you must choose the most appropriate option from several correct answers. As you gain experience, your speed and accuracy on infrastructure questions will improve, and your understanding will feel more intuitive. In the next episode, we will begin our detailed study of Domain 2.1 by looking closely at common computing devices. We will explore the differences in purpose, design, and connectivity between devices such as smartphones, tablets, laptops, and gaming consoles. We will also cover newer categories like virtual and augmented reality systems, and the wide range of Internet of Things technologies now in use. This will prepare you for both the identification and use case questions you can expect on the exam. Thanks for listening. Please visit baremetalcyber.com for more cybersecurity information and education, including a new children's series. For more information on books and more, follow us at cyberauthor.me.